I sit or stand?
Yes, ma'am.
Ma'am, shall I sit?
So depending upon you.
Okay.
You can sit here, so you can.
Okay, okay. Okay, sir.
Hello. Am I audible, ma'am, clearly?
Yeah.
A very good afternoon to all the respected delegates present over here and dear students. I am Pallavi Khobragade, as ma'am has already introduced me. I have completed my PhD in civil engineering department from civil engineering department in air pollution engineering. Then today's topic for the lecture will be source apportionment, emission inventory, and aerosol characterization. All this is related with source apportionment means we will be seeing here the topic from air pollution monitoring. As ma'am has already discussed about the data, how we are going to analyze the data. So data analyzation technique is known as source apportionment, which comes under the category of identification of sources. Like pollutants are classified as fine or coarse particulate matter. We will be focusing about particulate matter. So I'll explain you in much detail what particulate matter is and from what are the sources, how to classify the sources, how to identify the sources, from what are the emerging trends and how these data is analyzed these days. Okay, now then emission inventory, what it includes, we will study, and aerosol characterization. Aerosol is a part of particulate matter only. It is classified on the basis of their size. So how we can characterize aerosol using recent techniques. Okay. These are the contents of today's presentation. We will, I'll introduce about air pollution monitoring. At what position the air pollution factor is. We keep listening about this air pollution factor, that how polluted the cities are. Recently also we have seen 2-3 days before that in Delhi, we keep listening that the particulate matter concentration in Delhi is very high, and we keep listening that it is very much hazardous. So why and what are the reasons behind that? We need to identify, and what are the impact of various parameters, like what factors are also included in higher concentration, pollutant concentration. Then aerosols, I'll describe you. Then source apportionment techniques, types of source apportionment models which are used and why and which models are recently used. Then discussion about positive matrix factorization, I'll discuss about it, that emission inventory, and I'll conclude the presentation. Now, in this image, we can see first of all, we should know. I mean, I just want to ask one question. How many of you are aware about PM 2.5 and PM 10? What is the size of that matter, particular? Have you listened about this thing, PM 2.5? Are you able to imagine? Or if not, then from this figure, we can clearly identify here. See, this is the image of a human hair, which is about 50 to 70 microgram. Okay, micrometer. So in microns in diameter and the end portion. Okay, and below here is a fine beach sand, which is having a size of 90 microns in diameter. So now on the basis of these classification images, we can identify the size of PM 2.5. It means it is having a size PM 2.5. Means you can see that a human hair, that our hair is about 50 to 70 micrometer. And still this PM 2.5, how finer these particles are, and they are present in the atmosphere everywhere. And what are the sources, from which kind of sources they are generated. So now I guess you will be able to identify or think about these pollutants. Okay, how fine these are, and they are inhalable. They have many disadvantages if they are present in a more quantity. So air pollution, as per the States of Global Air Report, the last report studied in 2019, air pollution was at 5th leading risk factor. Okay, the central area, if we consider about this region, Raipur region, it is categorized into central region. It is classified under the industrial area section. due to which this concentration rises. Then Daipur is again surrounded by various industrial areas. PM is classified, categorized into PM10 and PM2.5. Generally, basically, we study earlier also SPM, that is suspended particulate matters, were studied, which were categorized from 1 micrometer to 100 micrometer. But now, during these days, it is rising. The issue about PM2.5 and PM10 is rising as it has very severe impacts on our health.
Excuse me.
Yes, ma'am.
Can you say something about this? Because why we are this using the PM 2.5 and in between there is no number with PM 2.5 and PM 10.
Yes, ma'am. Actually, the study of PM10, it categorizes the particulate matter, all including PM10, I mean 10 micrometer particles, and all below that particles. So under the study of PM10 size, all particles in having a size of 10 micrometer and below that particle, they can be studied. And the impacts of all can be categorized under PM10 health study or whatever study it will be included. And similarly, in case of PM2.5, the particle size range will be 2.5 micrometers and all the particle size below 2.5 micrometers.
No, my question is only then why the things is not in between this. The PM 2.5 and PM 10.5. Why the PM 7.5, 6.5 is not in between this?
But actually, this is a very descriptive study, and as per the Central Pollution Control Board, the effects, the consequences of these two sizes are much more.
Okay.
That's
So
why,
there are, we can say they are more dominating.
yeah,
as
more
compared to
dominating.
others.
Yes, ma'am. Yes.
Right.
Now, the study also includes interseasonal analysis, chemical identification, chemical speciation of the ingredients available in this particulate matters, and source identification approaches. Now, these are the standards provided by Central Pollution Control Board. They give a factor, air quality index, which helps us to identify whether a situation in a city is good or it is in a very poor or severe stage. So in Delhi, what we hear that the pollution levels is very much high. So what happens here, the hazardous pollutant level, that is the AQI index, which is calculated on the basis of this PM 2.5 and PM 10, falls under the category of what? Severe category. It means the AQI calculated at that location is, it means that the range for the AQI will be from 401 to 500. Okay. Now coming to aerosol, these are some images taken from SEM, that is scanning electron microscope, and whatever I was talking about, that PM fine and coarse particulate matter, if we see these particulates matter into the SEM, these are the images and which will be helpful for classification of those particulate matter on the basis of their shapes and sizes. Okay, so aerosols are nothing but the suspension present in the air, that is solid or liquid particles. They have direct effect on earth radiation budget, like warming. If the concentration of these aerosol particles is very much high into the atmosphere, it will lead to the warming. That is again identification of what elemental carbon is there or organic carbon is there. If we are able to identify all these things, then it means that the radiation budget effect in a particular location we will be able to estimate. Okay, like future prediction, whether cooling will be there in coming years or whether warming of the atmosphere will occur after a particular period of time, or which is more harmful and why, which kind of particulate matter should be present or should not be present in the atmosphere. And if they are present, then what things, what mitigating plans we can prepare for that. The government will be going to prepare for that. We have to study all these things. Now, it also impacts over the global climate change. The increase in cloud droplet concentration will occur, decreasing the droplet size, and many other things. The last one, I would like to focus that respiratory and cardiovascular diseases occurs, okay, in humans, which is a foremost and very much important factor, which we all about concern of. Okay. Now the direct impact of aerosol. Now categorization of aerosol is simply into natural and anthropogenic sources. Anthropogenic sources means the sources for which human beings are responsible. Okay, like biomass burning, industrial emissions, and vehicular emission sources. And in case of refracted light, what it means, this is the sun, image of a sun. The light coming from the sun, it is either absorbed by the particles or refracted by the particles. So under the category of natural sources, volcanic aerosols, wind-blown aerosols, and marine aerosols, what happens? This light is refracted back to the space. It means it is not having that much impact, whereas in case of this anthropogenic aerosol, these aerosols have a tendency to absorb the light, which retains the light in the atmosphere for a longer period of time, causing changes in the temperature and causing changes in the radiative budget, okay, which ultimately leads to heating or cooling of the atmosphere. Now, indirect impact of aerosol, what happens here? Aerosol act as a CCN, that is cloud condensation nuclei. What it is a water molecule attracting particles of about 1 by 100 the size of a cloud droplet, upon which water condenses. It means if we are going to say the water particles need some basis, something to accumulate over it, to condense over it. It means a finest particulate matter is present. Okay, so in case of this unpolluted region, what happens? Clean cloud formation is there. In case of polluted region, polluted cloud formation is there. Earlier, we were listening that rainfall pattern was very much good. Heavy rainfall was occurring and regular rainfalls were occurring. So what happens in case of these clean clouds? More bigger number of cloud and rain droplets are present, which helps in more precipitation and decreased cloud lifetime. Sometimes we observe here in any season that cloudy conditions can be observed, which are very much different in color and polluted. This means that in this figure, you can see the polluted cloud. This kind of clouds we sometimes can see here. Okay, what happens in such cases? More number of smaller size of cloud droplet particles are present in the atmosphere, which leads to less precipitation. Means the precipitation pattern also changes, which ultimately leads to changes in the... Anyone from hydrology here? Okay, it also, the precipitation pattern changes will lead to changes in the rivers or water flow, water availability. Okay. The chemical and morphological characterization is required for source identification. Here, aerosol characterization, that is aerosols we have discussed, they are categorized as chemically, they can be identified, or morphologically. The first image in aerosol I have shown you, that was the morphological. The image which earlier I have shown, that I'll show you once again. Yeah, this one. This is known as the morphological categorization or characterization of aerosol. Whereas in chemical characterization, what we do, ions, metals, and different elemental concentrations we identify. Means chemical constituents we identify. And both of them will help us to identify the sources from where these pollutants are coming. The first topic which I have discussed, that is the title of the presentation, source apportionment. It means all these things are required for source apportionment or source identification. Now, in heavy metal analysis, what types and what things are needed to be done? That is acid digestion method. Now, after this lecture, we will be going to the laboratory, environmental engineering laboratory, where I will show you how these processes are done. Okay, so acid digestion method, we will how these particulate matter are deposited. Air particulate samplers are provided, are available in the lab. There we keep the filter paper, and that filter paper is digested afterwards to analyze the constituent, chemical constituent present in the, and the amount of chemicals present in that particular region for a particular period of time. In this morphological characterization of aerosol through SEM EDX, it is done. We understand the morphology, we understand the composition. Composition can also be studied, and Again, it will ultimately lead to the identification of the potential sources in that particular area. So from this first image, this is the image of a blank filter paper, which we use for, in the instrument we use. Then the second image during low pollution days, image B, this shows that during low pollution days, you can see here very less amount of particulate matter is present over the filter paper. Whereas the last two images, which shows here that they are highly polluted. These are the filter papers where during very much highly polluted days, this pollution occurs. Now, source identification, how? I was talking about the sampler. This is the air particulate sampler in which the filter paper is kept. And this first image shows that this sampling is done at various locations, not only at a particular single location. After that, this sampling, we have to analyze the particulate matter in the laboratory, that is chemical analysis or morphological analysis of the particulate matter. We have to run some models to categorize these pollutants into various categories, and ultimately the last image is showing a vehicle. That vehicular particulate matter, vehicles are also a source of pollutants. Industrial emissions are also a source of pollutants. At what stage Raipur city is there, I will show you with some examples. Okay. Then particulate monitoring, again, I will talk about PM10 and PM2.5. The sampler required are known as respirable dust sampler. This I will describe the procedure in much detail in the laboratory. And PM2.5 particulate sampler, that is fine particulate sampler. One more thing I want to discuss is about fine and coarse particulate matter. That is, I've told that PM10 and PM2.5. The PM10 includes all the particulate matter from sizes 10 micrometer and less than that. So this category is, this study will be known as coarse particulate matter. Whereas the study of PM2.5, it will categorize the particulate matter from 2.5 and all the particulate, it means it includes every 1 micrometer particle also. Okay, and it will be categorized as fine particulate matter. The sampler used for this is fine particulate sampler. Filter paper sizes, various filter papers I will be showing you in the lab. Now, source apportionment procedures. First of all, we have to identify at what sites we are going to perform these experiments, whether that site is urban, suburban or background. Background site means where no artificial or where there is no sources available, like from humans, no industrial area is beside that particular location. Okay, no direct sources of pollutions are available. Whereas in urban category, we can say that if you are going to do the particulate monitoring at Ghadi Chowk, you have to install some sampler and you have to take the readings from that place. Then you will be able to differentiate between what amount of particulate matter is releasing from that vehicular pollution by after subtracting the background metal or background pollutant concentration. Okay. Then ambient sampling period means, according to CBCB, that is the Central Pollution Control Boards, this categorization of sampling periods is done, whether it is done for 8 hours of period or 24 hours of period, their frequencies and durations, source categories, physical and chemical properties required at the source and receptor locations, and source contribution estimate. Also, quality control. This factor is needed to be analyzed while performing the experiments. Now, the most simple method is that on the basis of monitoring data, we just note down the particulate matter concentration and we just put the result in a statistical way, whether where the pollutant concentration is high or less. Whereas in this case of dispersion models, what occurs? We simulate aerosol emission, formation, their deposition, their dispersion, and we estimate the concentration of pollutant. Here I am going to discuss about receptor models. Now, dispersion and receptor modeling. The input required for dispersion models is pollutant emission rate and meteorological parameter data. Like during winter season, we say that the pollutant concentration is very much high. We observe here. What may be the significant factor? Like if I'm going to discuss that meteorological factors like wind, precipitation, and temperature. of what factor you can say that the effect of that particular meteorological parameter on pollutant concentration. What you experience that during summer or during winter periods, the wind speed is very much high during what? In which season? During summer period, we experience that the wind speed is much higher during summer. So dispersion of pollutants will be more during summer or during winter. During summer, there will be the more dispersion. And what will be the effect over the pollutant concentration then? Less. Yes, good. The pollutant concentration will be less during summer season, whereas during winter period, we always keep listening that the pollutant concentration is rising to a hazardous level. Okay, this is due to stable wind conditions, means meteorological conditions also play a very much important role in this PM 2.5 and PM 10 concentration, leading to ultimately a very poor quality of air. Now, source-oriented models. These models are categorized as emission inventories, source-oriented models, and receptor-oriented models. And ultimately, the role of all these models is to identify the sources. I'll come to receptor models. Okay, I'll discuss about this in this lecture. Okay, ma'am. Ma'am, I want to continue now. I will just finish this presentation, and afterwards, means I'm having time or not, ma'am?
Actually, there is arrangement of IT outside.
Okay.
So, if
shall I continue
we can have
after 15 minutes? Okay.
So, are we taking break right now?
Ma'am, as you say.
If you want 2-3 minutes to summarize your present slide, then we can.
Okay. Actually, I need 15 more minutes to complete this.
Okay. So let us take a break.
Okay.
So we'll have a short break of 15 minutes, then we can resume the session and we can have a refreshment outside. The refreshment we can take. Can we have it right? Actually, I don't. I just did something. I'll come. You can get enough.